Every Python object secretly carries a number that determines its fate. Python tracks memory using a technique called reference counting. Every object has a hidden counter. It's reference count. That records exactly how many variables or data structures are currently pointing to it. CPython, the standard Python interpreter, stores this counter directly inside every object in memory. It is the core engine that drives automatic memory management. The reference count increases every time you assign an object to a variable, pass it to a function, or add it to a list, tuple, or dictionary. It decreases when you delete a variable with del, reassign that variable to something else, or when the variable goes out of scope, like when a function returns. When the reference count hits 0, Python immediately frees the object's memory, no delay, no waiting. Unlike Java's garbage collector, Python deallocates right away. This deterministic cleanup is why context managers and file handles work so predictably in Python. But reference counting has a blind spot: circular references. If object A holds a reference to B and B holds a reference back to A, neither count ever reaches 0. Python's cyclic garbage collector periodically detects and breaks these cycles, freeing memory that reference counting alone cannot reclaim. Python combines immediate reference counting with a cyclic garbage collector to manage memory. Understand both and you will write more efficient Python code. Ready to practice for your next interview? Interview Mentor lets you answer real questions just like this one. After each answer, you get a detailed grade and personalized tips to improve. Watch your scores climb as you keep practicing.